Hey, Algebra All-Stars, welcome back. This is part 2 of your second set of homework videos. I hope you guys are getting used to this format, and I hope that it is helpful to have this information at home to kind of watch at your own pace and listen to my voice at your own pace versus going through it really fast in class. So this video is about the properties of real numbers. I will be very honest with you. This is not my favorite thing. There's not really a whole lot of math magic involved here. It's just kind of memorizing rules. So we're going to go through this. We are going to take it for what it is and then move on to bigger and better, right? So bear with me. We'll get through it together. All right, so what is a real number? We touched a little bit in the first vocab video about classification of numbers, but a real number is a value that represents a quantity along the number line. So really any possible number out there. You will see this symbol, kind of like the double R. That stands for all real numbers. So when we get into functions later and domain and range, and we're talking about the possible numbers that could fulfill the solutions to an equation, a function, an inequality, if there's ever a time where the answer is, any possible number out there in the world, then we would represent that by saying all real numbers. It's basically another way of saying like infinity. But the properties of real numbers are a set of rules that allow us to create equivalent expressions from what we're given, and that'll help us solve problems. If we're given an equation, we have to follow some rules to solve it, and the rules that we're following are the properties of real numbers. When we're trying to prove things, properties will also come into play for us there. All right, so let's take a look. You have a worksheet in your packet that gives you the name of all of these properties, and then you can jot down some examples. I try and give you in each one of these some clues to think about, so you can add those to your notes as well. Really, whatever's helpful for you to remember. So the commutative property of addition, one thing that I will say about properties is that they are inclusive of addition and multiplication only. They don't work for subtraction. They don't work for division. That's a totally different set of rules. So you are really only going to be seeing adding and multiplying here until we get to some of the ones later down the line that apply to all operations, but you'll see exactly what I mean when we get there. So commutative property of addition. This property tells us A plus B is the same thing as B plus A. In other words, you can rearrange the addition problem and it doesn't matter, it's still going to equal the same thing. Your sign clue here is addition. And your verbal clue that I want you to think about is the word commute. We all know what commute means. We live in an area where people commute to DC or to like the military bases for work, to Richmond even. So commute means to go somewhere, to change the place from where you are. If you think about driving in the car to school or riding the bus to school, it doesn't matter where you sit in the bus, right? You're still going to school. You still have the same number of people in the car, in the bus. The order in which you sit in the car when you're commuting doesn't matter. You're still going to be that same number of people. So you can think about that. In the car, you can change your seat. It's still the same number of people. The visual clue that you can look for is a change in order of the elements. So 1 plus 2 equals 2 plus 1. That is an example of the commutative property of addition. You have your elements changing order and they're being added together. And this property doesn't have an inverse, so it doesn't work for the opposite, doesn't work for subtraction. Next is the commutative property of multiplication. Good news is, this is the exact same thing as the commutative property of addition, except we're talking about multiplication. So your sign clue here is to multiply. A times B equals B times A. Your verbal clue is the same. You're thinking about what it means to commute. You're going somewhere. You can change the order, but it's still going to equal the same thing. 3 times 4, that's 12. 4 times 3, also 12. So commutative property of addition and commutative property of multiplication just means you can rearrange the order of the elements on either side of the equal sign. Everything's still going to equal out the same. Okay, associative property of addition. Again, your sign clue is adding. A plus the grouping B plus C is the same thing as the grouping A plus B plus C. I want you to think about the word associate when you are thinking about the associative property of addition. If your group of friends takes up 2 lunch tables, it doesn't matter which friends fill table A and which friends fill table B. At the end of the day, you're all still the same group of friends. And that's the same thing here. It doesn't matter which elements are in parentheses. At the end of the day, it's all going to equal the same thing. That's your visual clue. Regrouping. The elements don't move, but the parentheses move. You're doing different groupings. So 2 plus parentheses 3 plus 4 is the same thing as parentheses 2 plus 3 plus 4. You can see the 2, the 3, and the 4 stay in the same order, but the parentheses are around a different group of numbers. That's the associative property of addition. Okay, multiplication, again, it's the exact same thing, but we're using multiplication instead of addition. So your sign clue, sorry guys, this should say multiply. My flaws have been exposed. This should say multiply. Your sign clue is multiplication. And 5 times 6 times 7 equals the same thing as 5 times 6 times 7. Okay, won't work for subtraction or division. The additive identity property. So your sign clue here is add. You have an addition sign. The word add is also in the name of the property. Oh, sorry. So the verbal clue, I want you to think about, you can't change your identity, right? You are who you are. So the only thing that will keep your identity, which is here represented by the letter A, the same thing is by adding nothing. If you're adding 0, then your identity won't change. So 0 changes nothing about the input. You get the same thing for the output. Your visual clue here is to look for a 0. If you see a 0 and a plus sign, then you're dealing with additive identity. 6 plus 0 equals 6. If my identity is 6, I have to add 0 to keep it the same. If I added anything other than 0, then my output would be a totally different number, and I don't want that. I want to keep it the same as the input. Okay. Additive Inverse. Okay, so you kind of have 2 sign clues here. One of them is addition, obviously, additive, add. But you also are going to have a negative sign, most likely. Okay, so your verbal clue is the word inverse. You should be adding the opposite element so that you bring the output to 0. A plus negative A equals 0. That's also kind of like a more convoluted way of just saying A minus A equals 0. But we want to think about the opposite of the identity to make the 0. And if we said A minus A, then it would not be living up to its name. So we're going to think about the opposite of the element, adding that to equal 0. So your visual clue here is to look for elements that equal 0 when added, or look for opposites. You know that the word inverse means the same thing as the word opposite. Okay, so 5 plus negative 5 is going to equal 0. If you have a 0 on the right-hand side, how did we get there? If we're adding, we added the opposite element, 5 plus negative 5. Okay, multiplicative identity. When we talk about the identity properties, the idea is that we don't change the identity. And we know that adding and multiplying are different operations. If we want to keep the number the same, we would add 0. That would not change the value of the number. A plus 0 equals A. Well, we can't hold that same thing true for multiplying, because what happens when we multiply something times 0? It becomes 0. So if we want to keep the identity the same, if I want to keep the A to equal A, I'm not going to multiply it by 0. I'm going to multiply it by 1, because anything times 1 is itself. All right, so our sign clue here is multiplying. And if we are thinking about the identity and keeping the identity the same, then we know that we have to multiply it by 1. If I gave you 5 times 1 equals 5 and said, what property is this exemplifying? You would say, well, that's easy. It's the multiplicative identity because I know that anything times 1 equals itself, the identity is staying the same. If it said 5 plus 0 equals 5, then you know that it's additive identity. So when you're multiplying, you multiply by 1 as to not change the identity or change the value of that number. And when you're adding, you add 0 as to not change the identity or not change the value of that number. Okay. Multiplicative inverse. So just like we added the opposite element, a plus negative a, we're multiplying by the opposite element. All right, and I'm sorry, you guys, I have one more typo in here. This should say 1 over a. If you bump down to the bottom, you can see the actual numerical example. 4 times 1/4 equals 1. I want the answer here to be 1. Your visual clue is to look for elements that equal 1 when multiplied together. You want to be multiplying by the opposite element so that your identity becomes 1. So we know that a whole number like 4, if we're thinking about our invisible math, is really 4 over 1. Well, the opposite of that is 1 over 4. 4 times 1/4 equals 1. The goal with multiplicative inverse is to have the whole problem equal 1. What do I have to multiply the element by to equal 1? I have to multiply it by its opposite. If I had 20, then I would need to multiply it by 1 over 20 to equal 1. Or if I had 2/3, well, what would I multiply 2/3 by to reflect the multiplicative inverse property? I would multiply it by its opposite. 2/3 times 3/2 equals 1. Okay, the multiplicative property of 0. This is a very fancy way of saying anything times 0 will equal 0, and we know that this is true. We learned this when we learned, our multiplications tables back in grade school. Your sign clue is multiplying. Anything times 0 will equal 0. So when you're looking for a visual clue, there will be a multiplication sign and a 0 on both sides of the equal sign. This could also be called the 0 property of multiplication or the multiplicative property of 0. It sounds much more impressive when you say multiplicative, but nobody's judging. Whichever one you can remember is the one that I want you to go with. Distributive property, probably the property that everybody is the most familiar with, even if you don't realize that that's what you know. We all know the distributive property. So your sign clue is to multiply, even though you don't really see a multiplication sign here. It's just understood that when you see a number bumped up against a parenthesis, you're being asked to multiply. And you have to distribute, okay, or give whatever's on the outside to both of the elements on the inside. Give what's outside the parentheses to each thing inside. So A times the grouping B plus C is the same thing as A times B plus A times C. You can't forget to distribute to the next element within the parentheses. If you just multiply this out as A times B plus C, then you would not have distributed to all the elements inside the parentheses. So you have to make sure when you are distributing that you are diligent in making sure you're multiplying by every element that's inside those parentheses. Your visual clue is that you see a number stuck to the outsides of a set of parentheses, and one of your examples here using real numbers is 3 times the grouping 2 plus 4. Well, that's 3 times 2 plus 3 times 4. Okay, so I lumped all of these together onto one slide because this is pretty straightforward. We're going to get more into this when we talk about our next unit, which is, or actually 2 units from now, which is solving equations and solving inequalities. But the addition, subtraction, and multiplication and division property of equality. So there's 4 properties of equality, and it's very simple, you guys. Don't let the fact that there's 4 throw you off here because the same rule applies. Whatever you do, whatever you add, subtract, multiply, or divide to or from one side of the equal sign, you must do that same action with the same value to the other side as well. Okay, so I'll say it one more time. In simplest of terms, whatever you do to one side of the equation, you have to do to the other side of the equation. This ensures that there is no change to the true value of each side of the equation, because remember, an equal sign represents that one side is the same as the other side. At the end of the day, when it all boils down to one number on one side and one number on the other side, they're going to be the same. So if we're going to change something about one side, in order to keep that balance, we don't want to tip the scales. So in order to keep that balance, we have to make that same change to the other side. And that's exactly what all of the properties of equality tell us. Okay, equality means the same for all. So you're doing the same operation on both sides of the sign. Here's some examples. If A equals B, then I'm going to add C to the left-hand side. Well, I have to add C to the right-hand side. If I know A equals B and I'm going to multiply A times C, I've got to multiply B times C also. Same thing with subtraction. If A equals B and I'm going to subtract C from the left side, I've got to subtract C from the right side. Same with division. A divided by C, well, then I've got to divide B by C also. And again, we'll get into this more when we get into solving equations and inequalities. But what you really need to know is that if you do something to one side, you've got to do it to the other side as well. Okay, the symmetric properties. Really, the sign clue that you are looking for here is an equal sign. If A equals B, then B also equals A. If two things are equal, both sides have the same value, like a symmetrical face or a symmetrical shape. It doesn't matter which order you read them, they are the same forwards or backwards. So if your visual clue is flipped elements, really with no operation, then you are looking at symmetry property. So 2x equals 6, that can also be read 6 equals 2x, and that's an example of a symmetric property. Reflexive. This one's pretty straightforward too. A real number is equal to itself. It's like looking in the mirror and seeing your reflection. A equals A. You see the same element on each side. 20 equals 20. That's a property of reflective. You're going to think about that equal sign as a mirror. And this is different than symmetric because remember, in symmetric, you can flip and read it kind of forwards or backwards. So there's got to be something different on each side. Not the case with reflexive. It's the same thing on each side, looking in the mirror. Okay, and transitive. If A equals B and B equals C, well, then I can understand that A has to also equal C. Your sign clue is lots of equal signs. You're going to have a couple different statements here. Your verbal clue is the if and then. Think about if two numbers are equal to the same number, then they are also equal to each other. If 4y equals 6 and 6 equals 3x, well, then can't I substitute that 3x in for the 6 and be able to say 4y equals 3x? Yes, absolutely. That's an example of the transitive property. Okay. If you have an if and then, if 4y equals 6 and 6 equals 3x, then 4y equals 3x. It's kind of like if you've got them set up, you can take that thing in the middle that repeats and kind of cancel it out. If I cancel out the 6 and 6, then I'm left with the 4y equals 3x. That's transitive. All right, you guys, that is it. Great job. I know we went through that pretty fast. Go back and watch again or pause as you're watching so you can take some notes. If you have any questions, be sure to jot them down so that we can talk about them in class. We'll do some practice. And then other than that, you have got your unit assessment coming up on Friday. So we will be kind of wrapping it all up with a review at the end of class tomorrow. Let me know if you have any questions, and we'll see you soon.